Hello, everybody. I will start my today's another live coding session. So today's of this question: serialize and deserialize binary tree. So serialization is the process of converting a data structure or object into a sequence of bits so that it can be stored in a file or memory buffer, or transmitted across a network connection link to be reconstructed later in the same or another computer environment. Design algorithm to serialize and deserialize a binary tree. There is no restriction on how your serialization and deserialization algorithm should work. You just need to ensure that the binary tree can be serialized into a string, and this string can be deserialized to the original tree structure. The input-output format is the same as how LeetCode serializes a binary tree. You don't need to for this moment. Yeah, this is something about the testing cases. Okay. Anyway, my task is to serialize the given binary tree and then, serialize it into the string. And also I will implement the function deserialize, which takes the string, serialize string and convert it back to the original, by maybe not the original, but copied binary tree. Okay, and I should return the tree. Okay. So let me clarify my understanding first. So in this question, I will implement two methods, which is serialize method and also deserialize method. Okay, so for serialize method, as I said, it will take the binary tree. So it will be given the root node, which is a node class. And this can be none, yes. And I will return the string. So this is a serialized string. And I will, in the deserialized method, I will take the serialized string and I will return the root of the build tree. This can be none if the given original root, tree was empty. Okay. So far, I've understood. Maybe I'm just interested in if root.var can be negative or 0. Yep, it can be negative or 0. Okay. Anyway, let me take a look at examples. So let's say I'm giving a tree like this. Oh, by the way, as the edge case, I have to take care. Sorry. That if I'm given the none, this is something, and then I convert it back to none in the deserialize method. I have to test this right there. Yep. For other case, something like this. Let's say I serialize this in 1, 2, 3, 4. But in this case, I can't figure out where the 4 is. Maybe this can be something like this. Oh, yeah. There for this one, if I do the level order traversal, it becomes 1, 2, 3, 4. Sorry, no. If I build the tree, I can build the tree, which is different from the original one, but can be read as 1, 2, 3, 4 when I do the level order traversal. So I have to be careful on this. My idea is, let's say something like none here. So for this none, I just put this. And for here, I put none and none. In this way, the tree now, serialized string looks like this. And when I do the level or the traversal, 1, 2, 3, and because this is none, I put none here, and then none again, and I put 4. And when I do the level or the traversal, I don't have any child as I don't have node in this level, as the child of these nons, 3 nons. I completely skip this and put the next non here as the child of 4. Yeah. So in this way, I could reproduce the original tree, the copy of the original tree. I think this works. Let me take a look at more example to confirm that this really works. Yeah, let me think of this. In this case, when I do the level or the traversal, it becomes like this. Yep. And I can create this one, yes, because I have 1, and I'm looking for the 2 childs, and I get n and 2. And at this moment, this level 1 is done. So I take a look at level 2. And for the level 2, the node is here in node 2. So I put 3 and none next to as the child nodes of this node 2. Like this. And this level is done. Here, I want the child of this 3, and I have n, so I put it in this way. Yep, looks good. And this level is done because in this level there is no any node. So that's the end of the deserialization. Good. Okay. Okay, so let me get started with this. Maybe I can use the DFS traversal, depth first search, as the traversal method. But I think this level of the traversal is good enough, so I will go with this. For time complexity, for serialize and deserialize, each of them, I need overban because I have to take a look at each node or number and put it as a child, or convert it into the integer. For space complexity, I need O of n in the worst case. This is a case when the tree is the perfect tree, perfect binary tree. So the height is, yeah. So it's quite balanced. Yeah, when the tree is quite balanced, it looks like this. And the number of leaf nodes is around the half of the whole nodes, which is n divided by 2. And these n divided by 2 nodes are stored in the queue when I do the BFS to do the level of the traversal. So for space complexity, this should be O of n. Okay, that being said, let me get started with the implementation. For this one, serialized method. Oh, by the way, I have to decide 2 things. How can I represent none, and which character I use as the diameter? No, not diameter. Later. Oh, I forgot. Let me search. Oh no, separator. Yep, diameter. Yeah. So I will go with diameter is this, and none should be represented as n. Yeah. Okay, let me go with this. So if root is none, I just return none. N. Maybe I should put it as a constant. Otherwise, I do the BFS here. Okay. So otherwise, I append string of output bar. Wait. No. After popping this out, I have to take a look at chars. Okay. So if char is none, I append non-char. Otherwise, I append char.var. Okay. And I have to append the diameter too. So after appending something here, I append this. And then here, for this child, I have to append this to the queue if this is not known. Yep. So this is it. Okay. Oh wait, what I'm doing here? Because root is not known, I have to append this. Oh, and in the end, I return the concatenated string. Okay. Wait, out never becomes none. Okay. Yep, looks good to me. Okay, so now we implement the Deserialize method. So data is the given string. So I firstly split this with diameter. Then I get chars. Actually not chars, but bars. Because it can be 2, 3, like 23. And I have to convert it into the, integers. Wait. If this is, none, it has to be converted into none. Can I use this? I forgot. Anyway, let me construct it with for loop. If this is delimiter, I append none. Otherwise, I append integer of this bar. Okay, so now I've created this list like this. So from here, I do BFS to construct the tree. So what can I do? So I do the traversal on these values, and also I have to create the tree. So let's say I have the queue and the first tree. Yeah. So when I have one, I put it to one, and then go to n. And here, this n should be the child of this one. So I put it here, and 2, and I put it here. Then at this moment, I have to move the pointer. And then here, for 3, it should be the child of this. So every time I find the bar, I put it in the queue. No. This is the binary string representation, and I have to convert it into the tree. Okay, so I use two things. Firstly, queue and current in tree. I will think of this with this. Firstly, queue is 1 and current pointer in the list and current pointer in the tree. I need this. So firstly, queue in queue 1 is here, and list is point to list pointer is here, and tree pointer. So actually, this is node is pointing to here. Then I move this to here. So at this moment, I pop out this one, and PL should be, I put n and 2 to the child of this in this way. After that, it's quite confusing. Let me think if there's a better way. Yeah. Okay, so the naming queue is not clear. Maybe I name it like no child knows. Yeah. So this, after adding one, after traversing one, I put it to here. Then I find this one and I pop out this one from this queue. Then I put PL this and this to the child. And when I have the non-null value, I put it here. Now what happens is PL is here. Wait, where is it? No child knows. 2. I connect 2 and 3 to this. I move PL twice. Then I got none. So I pop this out. Oh no. And when I traverse this 3, I put 3 to here. Then because I have none, I pop this out, and none should be connected as a child of this and this. So I first read this and first read this. And then I come back here. Wait. Sorry, 2, 3. Yep. 2, 3. So when I have n and 2, they should be appended to, put as the child nodes of this one. Then I move the pointer to 3. Then this 3 should be used as a child of this and this. I move this twice. And each time 3 and null are put as a child here. Then when I create this 3 node, I put it into the queue here. Then I got n, so n should be here and here. Okay, so I've clarified the process. So let me sort out. So traverse for each bar in the list. Pop out from queue, out dot left and out dot right should be okay. I take a look at 2, bar 1 and bar 2. This should be put as the child of the popped out node. Then if this bar 1 and I create a node here, then so this is the case if bar 1 is not none. Actually, I'm writing the code. Yeah, I pop it here, then push to queue. Yep. And I do the same for bar 2. So this is a basic algorithm. So for each pair of bar 1 and bar 2, I pop out element from queue. This becomes a parent node. So for bar 1, if this is none, I just, out.ref should be known and that's it. Otherwise, I create a node and append it here as a ref child, and also push this as a queue into the queue because this needs the child value. And I do the same for bar 2 in line 50. Good. Okay. So let me implement this. I return none. Otherwise, the returned tree should be bars 0. This one. And from here, I need a queue. And firstly, this reach should be inside of it because it doesn't have a children yet. Yeah, this is it. And the okay. So if I is still in the list, firstly I pop out. So this should be the parent node. Okay. And I take a look at bars I. If this is not none, so this is the ref child. Like this. So parent dot left is child. Yeah. I think this is it. Oh, and also I have to append this to Q. Yep, this is it. Okay. And I move I. And I do the same thing here. But this time I put it as the right child of the parent node. Yeah, and this is it. And here, this I should be exactly the end plus 1. So should be here. And I return read. Okay, this is it. So let me quickly dry run with the code. Like 1 and 2. Okay, firstly with the edge case. So in the edge case, none is given. So when none is given, root is none. So this returns self.nonchar, which is n. Okay. And in the Deserialize method, because data is n, splitting with delimiter, it creates a list of factor n only, and string var is n, which is delimiter. So I append none to the vars list. Yep. And here in line 109, var 0 is none, so I return none. Okay, so I basically pass this test case. Okay. Okay, the second case, in this case, so I try to serialize, but root is not none. So I create a queue. Okay, so root should be now root.var. So this should be 1, like this. Then while q is not 0, q isn't empty, I pop out this 2. No. Pop out this 1. And take a look at node known and 2. The child is firstly known, but I append parameter this. And because child is known, I append non-char, and that's it. And then come back to the right child 2. So I append the parameter and then 2, string 2 in line 106. And then this 2 is pushed into the queue. Yep. And I come back to line 99. And because this is none, queue is not empty, I pop out this 2 as the out. So now out node is 2, left child and right child, both of them are none. So in both cases, in both nodes, I append the parameter and then value string 2, delimiter and none, delimiter and none. Yep, okay. And I don't append anything in line 104. So and then in line 109, I return 1 and 1 split end, split 2, split end, split end. This is return. Okay, so for this is expected format of serialization. For deserialize, firstly in line 115 to 120, I split this string with delimiter. Yep. Then for each 1 and 2 and n, I converted it into none or this should be node. 3 node. Okay, converted into the 3 node. So this now becomes node 1, then num, node 2, num, and num. Yep. And for Q, read is bar 0. Oh, I'm initiating the node here. Oh, sorry. I actually don't have to make it Q node yet. Yep. So it's just like this. Okay. So in line 125, read is pointing to node 1. Then Q has this node 1. Yep. Then I begin from I0 until 4. I speed up. When I is 0, but 0 is 1, so I create a child node. Sorry, this should be popped out. So 1 dot left is child node 2. Like this. Then parent dot left is child, yes. Q dot push child, so 2 is appended to the Q. Okay. Then I plus equal 1. So I is now 1. The vals I is now, where is it? None. Yep. So I don't do anything, and I plus equal 1. So it becomes now 2. Yep. I didn't do anything here. Next, I is 2. So in the list, it's now, sorry, I begin with 0. No, I should begin with 1 because I0 is already used. So 1 becomes 2 and get none. So now I do nothing here and I push node 2 as the right child. Yeah, good. Then now it looks like this. I is now 3. So now it's 0, 1, 2, 3, none. So next, none, none. So I don't do anything. And I is incremented twice. So I becomes 4 and then 5. In the end, this I is equal to the length bars, yes, and I return read, which is pointing to node 1. Yeah, so I return this structure. Okay, this is completely as expected because originally this was like this. Okay, good. So I passed this case. Okay, so that being said, I'm pretty confident in my code, so let me submit. Self is not defined. Maybe I don't need self here. Okay. So string body is equal to delimiter. Wait, where is it? Delimiter is none, and oh no, this should be non-char. Okay, and I should append non-char here. No, here this should be delimiter. Okay, let me check. Delimiter here is okay. Non-char here is okay. Here I split with delimiter, yes, and I check if this is non-char. Okay. So deck doesn't have push, so this should be append. Append 2. Good, accepted. And accepted, great. Okay, so let me quickly wrap up. So today I solved the question, serialize and deserialize binary tree. In this question, I'm giving a binary tree, and firstly, in the serialize method, I serialize this given tree into some string. And in the deserialize method, I deserialize the given string into the original tree structure. Okay, so basically what I did is doing the level of the traversal, and for serialize method, I, created the string. Yeah. The only thing I had to take care is if there is a node which doesn't have any child, I have to put non-non as the position of those child nodes. Yeah, like this. Okay. And for deserialize method, I basically do the same. Level of the traversal. Yeah. But it was a bit hassle to write this, iteration. Because I have to take care. Basically, I traverse the bars and I have to take care which node is the parent of the current bars node. So I had to keep track of it. Basically, I could do it with a cube data structure. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.